Welcome back. In this video, we're going to prove some trig identities. We're going to start with this first identity here, which is sine squared x times tangent squared x equals the difference of tangent squared x minus sine squared x. And when we think about proving, we have some logic, per se, that we like to use. Not per se, it is. So we're either going to work on one side only, left side or right side. We can work on each side, but we do want to be very careful that we never move terms from one side of the equation to the other. So what we might try to do would be to work on the more complex side first, somewhere there is an algebraic manipulation for us to carry out. If we're dealing with fractions or rational expressions, common denominators multiplying by 1. And then the other strategy we use is to convert everything into sine or cosine. So let's look at solving this. My first step is to I like to build a wall, all right, because that helps me remember that we're never going to cross from one side to the other. So we've got our border wall here. In this situation, I think subtracting them looks a little bit harder than multiplying. However, one thing that we might want to do would be to go ahead and turn everything into sine and cosine first. So that just might help me look at this. So I've got sine squared x times tangent. Remember, tangent is sine over cosine. So tangent squared is sine squared x over cosine squared x. And then I've got sine squared x over cosine squared x minus sine squared x. So on the left, that's very easy for me to simplify, but on the right, I have to do some work. So I'm going to go ahead and simplify a little bit on the left, combining those numerators. And I have sine to the fourth power of x over cosine squared x. So now I'm going to apply some algebraic manipulations to try and make the right side look like what I have on the left side. So I did do a little bit of work on both sides, but just make sure you know I didn't move any terms from one side to the other. That's really important for us to remember. That's a huge no-no. So continuing to work through this problem, I'm going to try and add these terms together. And I know I said add, but in my world, adding is the same as subtracting. It's just in the opposite direction. So I'm going to try and get a common denominator. I've got sine squared x over cosine squared x. And right now that sine x is over a little invisible 1. So I'm going to take that sine squared x over the invisible 1, and I'm going to multiply by 1, and I'm going to choose that 1 by looking at the other denominator, which is cosine squared x. So I'm going to multiply by cosine squared x over cosine squared x. It's perfectly legal to multiply by 1 because we're not changing the value of the side, we're just scaling it up. All right, so that leaves me with sine squared x over cosine squared x minus sine squared x cosine squared x over cosine squared x. At this point, I'm going to add those two fractions together, combine them into one term, which gives me sine squared x minus sine squared x times cosine squared x all over cosine squared x. So we're working on the right to try and make it look like the left. And so far we're pretty close, but we're not quite there. So we need to manipulate, and maybe thinking about some algebraic operations would help us. I need to somehow turn this numerator into sine to the fourth x. I already have my denominator cosine squared x, but I need my numerator to change. Is there anything I can do? And the first thing I see would be to factor out a GCF in that numerator. So that's sine squared x times 1 minus cosine squared x. That's what I have in the numerator. Again, all still over cosine squared x. And we're almost there. Think about what we know. Are there any identities that we can sub in? And hopefully you recognize that 1 minus cosine squared is a Pythagorean identity. That is equal to sine squared x. So now I have sine squared x times sine squared x over cosine squared x. So I substituted sine squared in for 1 minus cosine squared x. And look, we're pretty close. What are we trying to get to? Just going to bring my left side down. We had sine to the 4th x over cosine squared x. And are they equal? Sine squared times sine squared is sine to the 4th of x. At this point, we are done. We end our proof and we say, therefore, so in this example, we proved a trig identity. We started with something and we said, all right, we're going to show that this is a true statement, which we did. We manipulated mostly on the right to create something that was true. We were done. We write therefore. All right, so more videos coming up. Hang tight.